Okay, so we're going to start off reviewing stuff that we learned in Math 120. So functions and their representations. So homework is going to be on Tuesdays as usual. And objectives, we're going to use set builder notation and interval notation and identify domain and range. So set builder notation and interval notation are used to identify intervals for domains and ranges. So set builder uses the inequality symbols. Interval notation uses parentheses for endpoints that are not included and for infinities, technically positive and negative infinities, and brackets for endpoints that are included. It's always written lowest value, comma, highest value. So this is very important right here. Lowest, comma, highest. And for set builder, we use inequality symbols here. Let's continue. So it says, example, complete the following table. So set builder notation, we have, I read this as x is going this way greater than -4, or, and then with this arrow over here, x is going to be less than or equal to 5. On the number line, so I like to read it from the middle to the left. So again, one last time, x is greater than -4, and from the middle to the right is going to be x is technically less than or equal to 5. So the line graph representation for this is going to be, I only need to put my important numbers here. So -4 is to the left of 5. And we have, because of this notation right here, we're going to have a parentheses. And because of the less than or equal to, we're going to have a bracket right here. And technically everything else in between is also our answer. So for interval notation, it's going to be parentheses -4, again because the x is only greater than -4, it's missing the equal to part. And for 5, since it's less than or equal to, it's going to be bracket because it has the equal to part. Now the next one, this one is read x, and then that vertical line is going to be such that x is less than or equal to -2, or x is greater than 0. So our line representation, -2 is to the left of 0 on the number line. So it's going to be less than or equal to -2. So for this notation, less than or equal to, so the bracket needs to be pointing in the direction of the fact that we want values less than -2. And again, because it's equal to, we're going to put that bracket. And all of this is also part of the answer. And then for the or, x is greater than 0. So here for greater than 0, since it's not equal to, we're going to put a parentheses, and the parentheses has to be facing the values that are going to be part of your answer. So for x greater than 0, values to the right. So our parentheses, is going to be in the direction of the right hand side. So there's our answer graphically. And so our answer in interval notation. So I'm going to highlight here in another, because of this arrow, this is going to be from negative infinity, because that arrow that's in purple goes forever to the left. So I'm going to put here, it's going to go from negative infinity, and infinities always have parentheses, comma, all the way up to negative 2. And then we're going to have that bracket. And then, then we put a U for union because it's two separate pieces. And then we're going to have parentheses 0 all the way up to infinity. And again, infinities, positive or negative, always have a parentheses. And why is it going to be infinity? Because this arrow right here goes forever to the right. So it's going to be positive infinity. Now for the rest of these, if you want to pause your the video and try to do it yourself and then come back and play the video and check your answers, that'd be awesome. That's technically what we would be doing in the face-to-face class. Okay, so for here on the next one, it says we have a line graph representation. It's -7. It has a parenthesis, so we know it's not equal to. And it's shaded to the left. So this is going to be x has to be less than -7. And so for interval notation, it's going to be from negative infinity with a parentheses all the time for infinities. And because of this arrow going forever to the left, that's the reason why we have that negative infinity. All the way up to 7, and the 7 is not included. So we put a parentheses around it. The next one is bracket -2 to bracket 6. So our interval notation is already done for us. So bracket 2, the 2 is included, so we put a bracket on it, and then 6. So the set builder notation is going to be x has to be less than or equal to 6, and x has to be greater than or equal to -2. The next one, this one right here, I want to make a little correction. So it's going to be from negative infinity to -4. Sorry about that. And then from -3, and take that off. Sorry, I apologize for that. So the line graph representation. So we're going to shade from negative infinity to -4. And -4 is not included because we have a parentheses on it. So on the line graph, we just put -4. And we do this right here. And then it says from -3, and this should be a comma 3. So from -3 to 3. And they are in both in parentheses. And then from 3 to infinity. So the set builder notation for this one's going to be interesting. We can say that x such that x is less than -4, or x is less than 3, greater than -3, or x is greater than 3. And for this last one, it's going to be bracket 2 to infinity. So bracket 2 to infinity, I just have a 2. I have a bracket. It has to face in the direction of the other numbers that are included. So since I'm going to infinity, it has to be facing to the right. And I go this right here. And this one is just x is going to be greater than or equal to 2. So I put here, remember, a function is a relation in which each element in the domain corresponds to exactly one element in the range. The domain is the set of all x values. The range is the set of all y's. And the relation is a function if it passes the vertical line test. So I call it VLT. Every possible vertical line intersects the graph at only one point. So we have these examples here. I'll start off with this one. And does it pass the VLT, which is the vertical line test? And we're going to do the domain and the range. So we have g of x is equal to the square root of negative 2x. So let me have Desmos here. And so I already graphed it, already put it in Desmos. So square root of negative 2x. Let me zoom this right here. And I'm going to pick some values here. So negative 2. So this would be the square root of negative 2 times negative 2, which is the square root of 4, which is 2. And I can also pick negative 8. So the square root of negative 2 times negative 8 is the square root of 16, which is 4. And I can also do 0. So the square root of negative 2 times 0 is just the square root of 0, which is 0. Now, I can also do here a table for it. And I'm going to press on it. And I can actually just check my answer. So for negative 2, it's definitely 2. For 0, it's 0. And I'm missing negative 8. So I can go in here and put negative 8. And I definitely get 4. And if I were to graph it, so I get a graph that looks something like this. And this is important. This is an important point. 0, 0. Now, so my domain. So my domain, I'm going to put it up here, is lowest x, comma, highest x. And my range, so I do D for domain, R for range, is going to be my lowest y, comma, highest y. All right. So my domain, my lowest y, my lowest x, I'm going to highlight. This arrow right here is going forever to the left. So since I'm going forever left, let me write that down. It's going to be forever left. And it's this one right here. And because of that, my answer for the lowest x value is going to be negative infinity. And it always has parentheses, comma, and then this point right here, my x value, actually I should be more, this x value right there, it just stops right there. So I'm going to put this right here is going to be 0. And it's an actual point on the graph. It is included, and I'm going to put a bracket. Now my range is my lowest y, comma, highest y. So my lowest y is going to be the lowest point on the graph, and the y value for the lowest point on the graph is this one right here. So my lowest y is going to be 0, and it is included. So it's going to be a bracket. And this same arrow that I'm going to highlight, what was the highlight that I used? This one. This one right here, that same one, is going very slowly forever up. And so this answer is going to be bracket 0, comma, infinity. The next one. So the next one here has g of x is equal to 3x minus 5 divided by x plus 5. So in Desmos, we would graph it. And I put parentheses in it. So I'm not going to graph this one. I'm going to graph this one now. I don't want to graph this one. Okay, so this one looks something like this. So it looks like at 5 we have a vertical asymptote. So I'm going to zoom in here. So let me do this here. No, that's not what I wanted to do. Be nice to me, technology. Yeah, but I don't want this one. Okay, there we go, I think. Okay, so at -5, I'm going to do here. We have a vertical asymptote. And we can get a table of values. Just in the interest of time, I am going to write them down. You can check them with your graphing calculator. So at -9, our answer is going to be 8. At -7, it is 13. At -5, you're going to get an error. And I added some more. So at -3, we're going to have -7. At -2, we have at -1, excuse me, we have a 2. -2. At 0, we have -1, and at 5, we have 1. So if I'm going to graph them, so at -9, we have 8. So 5, hang tight. So at -9, we have 8, so I can put 8 right here. And I'm just going to graph them. At -7, we have 13. -5, we have an error. -3, we have -7. -1, we have -2. 0, we have -1. And at 5, we have 1. So let me graph it. Oops. Some of you might have caught my mistake. Let me fix it. Let me erase here. If we were in a face-to-face class, some of you would have gotten some points here. It is what it is. So at -3, it was -7. So right here-ish. Okay, so let me connect the dots. So our graph looks something like this. And this graph looks something like this. We actually have a horizontal asymptote at x equal to 3. At 3, we have something right here going on. It doesn't cross. So I should probably fix this. There we go. Okay, so let's look at our domain. So our domain, we have 2 pieces. So our graph is broken into 2 pieces. So our domain is the lowest x value, which is the furthest leftmost part of the graph. So that's going to be this right here. So it's going to go forever left. So let me write that down. So I'm taking this really slow. Comma. And for this piece of the graph, this part right here that I'm going to highlight, this part right here, that is going to end up trying to get really close to, but it never does, to x equal to -5. And maybe I should accentuate this a little bit more. This this vertical asymptote, excuse me, this part of the graph is trying to get really, really close to it, but it'll never touch it. So it's trying to get close to -5. So forever left is going to be -infinity, always with the parentheses, and -5, again, because of that vertical asymptote, that part of the graph never touches it. So -5 is not included, and we show that with parentheses. But we're not done. We also have to address the domain and range of the other piece of the graph. So the other piece of the graph is going to be, so we have a U here, so hang tight. We have a U here, and it's going to be the lowest x value is the leftmost part of the graph. And so let me highlight it here. So this part right here, I'm going to put it right here. It's going to get very close to, but never touch, -5. So I'm going to put here -5. And since it never touches it, it's going to be a parentheses. And then this part right here that I'm going to highlight in a different color because it's going to be too dark. That's too light. Sorry about that. This part right here is going forever to the right. So I'm going to put it here, forever right. And so we're going to write that as -5, comma, to infinity. Now I ran out of space, but we have here at the bottom. So now that was just for the domain. So it's going to be, after I took up all the space, it's this and this. Now for the range. For the range, I'm going to look at the lowest part of the graph. So the lowest part of the graph, taking this really slow, is this part right, is that part right there, and it's very dark. So that one is going forever down. So here, I'm going to put forever down. And then this part of the graph that's in gray is trying to get close to 3, but it never does. So it's going to be (3) parentheses because it never does. So forever down is going to be -infinity to -3 in a parentheses. And for the second part of the graph, let me use a highlight here. This part, the lowest y value is trying to get really close to 3, but it never does. So I'm going to put it here, and it's going to be 3, comma, and then this part that's already highlighted in green is going to go forever up. So that's going to be parentheses 3, comma, infinity, always with parentheses. So the answer for the range, nice and complete, is going to be this one with a U, because we have two different pieces, along with this one. All right. We have 2 more. And again, you could pause and try to do as much as you can on your own and then just check your answers. Here we go. So for 3 minus 2 times the absolute value of x, again, you can use your graphing utility, but for the answer for -3, it would be 3 minus 2 times the absolute value of -3, and that's going to give you -3. So for -3, we get -3, which is this point. And then for the next ones, for 0, so 3 minus 2 times the absolute value of 0 would give you 3, which is that point. And for positive 3, we will get 3 minus 2 times the absolute value of 3, and we get negative 3 again. It's this point right there. And then when you would connect the dots, even though the graph was given to you since the beginning. Okay, so our domain is lowest x, comma, highest x. So our x's run from left for the lowest values and to the right for the highest values. So our lowest x is right here. Oh my goodness, that's very bright. Right here. So our lowest x is going to go forever to the left. And then I'm going to highlight this one. This one, that arrow is telling me that my x's are going forever to the right. And so forever to the right means that my x values are getting bigger, so they're headed towards positive infinity. And forever to the left means that my x's are getting more and more smaller because they're getting more negative. And that's going to be negative infinity. My range, my lowest y value. So my lowest y value is going to be, because of these two blue and both the blue and the green. That's not what I wanted to do. So because of the blue and the green one, my lowest is going to be, these are going forever down. Both of these are going forever down. And forever down is negative infinity, comma. And my highest y value, this point right here is 0, 3. And my highest y value is going to be that y value right there. And it is included, it is part of the graph. So negative infinity, comma 3 is your range. So g of x is equal to negative 2x. So for negative 1, we get positive 2, which is that one. For 0, we're going to get 0, which is that one. And for 1, we get negative 2, which is that point right there. And this graph says, sorry about the background noise. There's the graph for it, the piece of the graph that we're only interested in. Okay, so our domain is our lowest x. So this point right here, let me highlight it. This point right here has our lowest x. And the coordinate for that is negative 1, comma 2. So let me highlight here that negative 1 is our lowest x. It is part of the graph, so it's going to be bracket. And then our highest x value this arrow tells me here that we're going forever to the right. Very slowly, our x values are getting bigger. So our answer for the domain is going to be negative 1, comma infinity. Now our range. So our ranges are our y values. So it's going to be the lowest y, which is the bottommost part of the graph, all the way to the highest y, which is the topmost part of the graph. Okay, so our lowest y value is going to be this green part 2, and this is going forever down. And the highest y value is this y value right there. And that one is 2. And it is included. So forever down is going to be negative infinity, always with a parentheses. and our highest y value is 2 with a bracket. Now we have this scenario. It says a golf ball is hit on its vertical height h in feet above the ground after t seconds is given by h of t is equal to 64t minus 16t squared. And I put here hint, make a table and a graph it. The problems that we need to address are what is the initial height of the golf ball? So the initial height of the golf ball. So what is the initial height means that we're looking for h, and the initial height technically means at t equal to 0. Our time is equal to 0. The golf ball has not been hit. So at time 0, well, hopefully it makes sense that it's on the ground. So here it is mathematically. So wherever I see a t on the equation, I'm going to put a 0. So h of 0 is equal to 64 times 0 minus 16 times 0 squared. And again, here's my t, and there's a t, and there's a t. And wherever I see a t, I put 0. And yeah, we do get that our answer is 0 feet. What is the height of the golf ball after 4 seconds? So after 4 seconds, so that means that this 4 means that our t is equal to 4. And wherever I see a t, I'm going to put 4. So h of 4 is going to give me the height of the golf ball after 4 seconds. So 64 times 4 minus 16 times 4 squared. And you do that in your calculator, and you're going to get 0 as well. So 0 feet. And it says if the golf ball spends the same amount of time going up as coming down, after how many seconds does the golf ball reach its maximum height? And what is the maximum height? Okay, so here we might want to graph it. Some of you might say, well, at time 0 it's on the floor, after 4 seconds it's on the floor, and it spends the same amount going up and down, so the highest point should occur after 2 seconds. But let's just confirm that with the graph. So here we go. So I'm going to graph it here. So I'm going to not graph this one, and I'm going to graph this one right here. And if you notice, it doesn't have a t, so for graphing calculator purposes, anytime a variable other than x is used, you need to use x anyway. So here's our graph. Now, you need to realize that our x's are keeping track of time. So we have no right of being in the negative t values. So technically here, and this is going to help us with our domain and range. For our graph, for our purposes, we should only be looking at this part of the graph right here. This line is off, but I'll fix it. So here this is 0, 0. This one is 4, 0. And this point right here is 2, 64. So now we can answer the questions here. So for part C, it's at t equal to t equal to 2 seconds. Is when the golf ball is going to reach its maximum height. And what is the maximum height? H of 2, which is the maximum height, is going to be 64 feet. And it says, give a reasonable domain D for the function h and explain what it represents. So again, when you use your graphing calculator and you just sketch the whole graph that it gave you, and you don't take into consideration the real world application of it, the fact that you can't go negative, go back in time, t can't be negative. and the height can't be negative. Once it hits the ground, it hits the ground. It can't dig itself a hole. Um, Having this graph right here is very, very beneficial. So give a reasonable domain. So again, domain is going to be lowest x, comma, highest x. So our lowest x is this value right here. And our highest x is this value right here. And since the points are included, then it's going to be bracket 0, 4. So give a reasonable domain and explains what it represents. So time 0 seconds is right before the ball is hit. And then at time 4 seconds is when the ball lands. Give a reasonable range R for function h and what it represents. So our range is going to be our lowest y, comma, highest y. Okay, so our lowest y, looking at the graph, our lowest y value happens to be this y value and that y value. That's our lowest y. And our highest y is this value right there. All points are included. They're closed circles. So it's going to be bracket 0 to 64. So what does it mean? Actually, the initial height, the initial and final height of the ball is 0 feet. The maximum height is 64 feet.